Okay, so good afternoon. Today I'm trying to solve a school contest. Yes, contest made for schoolboys and schoolgirls. By ISAF27. So usually I don't participate well in them, but today we'll try anyway. Also the problem is today I don't have an interactive whiteboard, so I'll try to explain without it. Maybe a notepad will be useful. So, Kirill wants to weave the very beautiful blanket consisted of square patches. So XOR of upper left square is equal to XOR of lower right square. And XOR of lower left equals to XOR of upper right. What the hell is that? What the hell is that? Oi. I think we can make all these XORs zeros, don't we? Yes, maybe we can make all XORs zeros. Yes, I guess we can. So Vij equals I times 256 plus j. Yes. Yes. So let's see. Let's see. Yes. So is it source? Yes, it is source. From concept test 1. Ah, maximum number. I need to print the maximum number. Sorry. Okay. Let's go. Little Sasha has two friends whom he wants to please with gifts of the 8th of March. To do this, he went to the largest shopping center in the city. There are n departments in the mall, each of which has exactly 2 stores. For convenience of number departments with integers from 1 to n, it is known that gifts in the first store of the ith department cost AI rubles, and in the second, BI rubles. Okay. He wants to pick up gifts in such a way that the price difference of the most expensive gifts bought to friends is as small as possible so that no one is offended. Okay. Interesting problem. So we have 2 columns of values, and we want to choose a value from each column so that the difference of maximums is minimized. Okay, first of all, let's look at the maximum numbers in both columns. Hmm. So assume that, for example, for the first guy, for the first friend, we chose that A first is the maximum gift that he will receive. So in this case, we need to choose, and also A1 is the maximum. It is greater than the gift that the second friend will receive. So we need to choose we need to choose. So if in some column, in some row AI and BI, if we have AI less than A first, if we have AI less than A first, then we can easily take AI. And otherwise we need to take BI. Yes. Otherwise we need to take BI. And we need BI to be as small as possible. As big as possible. But still less than A first. So okay, let's sort pairs by A. So we try to take A1, A2, etc., AN. And in each case, okay, for example, let's assume that AN is at most BN. So in this case, I think we need to take, we can try both. So for example, let's assume that AN takes this. So we need to take maximum from here, the nearest number to AN from B1, B2, etc., Bn minus 1. And otherwise we take this. And Bn can be very little. So let's choose the maximum. For example, maximum is AI. So we need the number. First of all, we need to take all numbers from B I plus 1 to Bn. We need to take them. And also, maybe we can take something among A first, etc., AI minus 1. And we need it to be as near as possible to AI. think we can just use std set, and that's it. 3 seconds, 5,000, 500,000. Maybe it's too much. I think so. How can we pass from some state to the next state? So we replace AI with AI plus 1. So we eliminate one number from these. And also we need to go to the next number here. Okay, I think that's okay. So, okay, let's go. Let's go. I spent too much time on this. But it happens. So let's sort them by AI. So we have two types of B. Set int small. So okay, and in the beginning all B's are of large B's, or of a large A's. So it's multiset, I guess. Insert b.y. Okay. Now we go through all of these numbers. And what do we say? So current A is equal to V vi.x. So this is current A. Also, we need to make some initial uns. I guess initially it's like this. So what do we do then? So int b equals, we need to make some maximum. So first of all, we need to eliminate the corresponding B from large A's. Yes. So we find it here and we eliminate it. Eliminate. IT large. Great. So now we need to find the maximum. So if it is not empty, we say that B equals B of large A dot R begin star yes. So and also we can choose some number among A's. So what do we say? We say that now, so if B of small a dot empty, if it is not empty, let's take yes, let's take B of small a dot lower bound of current A if IT small is not equal to B of small a dot end, we can say that if ups of B minus current A is less than ups of IT small minus current A, then B equals IT small. And now we say if IT small is not equal B of small a dot begin, first of all we minus IT small, and then again do this, and then we say ans равно equals minimum of ans and these ups. Excellent problem. Yes, and in the end we forgot to do something. We need to put IT, no, not IT, but B of small a dot insert vi dot y. No, it's not very good. Okay, let's see what's happening here. So for some reason that answer is 7, but it is not true. The answer is 1. So let's find how can we make it 1. I think we can take 4 here and 5 here. Yes. We can take 4 here and 5 here. Let's try and do it. Okay, so now it is 4. Now it is 4. I need make it like this. Okay. I think it is solid. And it should work. No, it is not solid. Why is it 0? Because I can make both maximum 5. Yes. What about it? Also 0, but why? I can again make both maximum 5. Zero. The answer is 3. So what's the problem? I don't understand why this solution is wrong. I really don't understand. So again, I have left numbers sorted and right numbers. So I chose AI. It will be taken. So in this case, all large B's, I have to take them. But if I want, I can take some small number instead. Maybe if n equals 2, I do something wrong. It should be 4. And it should be 0. Yes, so I take AI. So first of all, I need to take all these numbers. But also I can take some numbers which are really near AI if I want. If I don't want, I simply don't take them. Ah, I get it. I only can take them if they are greater than my number. Yes, yes, I get it. I get it. So I only can take them if it small is greater than they are greater than obligatory B. Yes. This was an error. I need to make a test where this is wrong. I guess I can take something like this. So in this case answer is 1, but I think I could make it 0 if I removed this. Yes. Great. But still, by 151st place, it's awful. What about France? Nah. 8 minutes, guys. 8 minutes. 8 minutes. And he's not even first one. Who is the first? Somebody. Problem C. The boy Vita loves to listen to music very much. He knows that n albums are due to be released this Friday, each ith of which contains ki tracks. Of course, Vita has already listened to all the tracks and knows that in the ith album the coolness of the jth track is equal to aij. So we need to order some arrays of numbers in such a way that maximizes the number of prefix maxima. Okay, it's a nice problem. First of all, if some album does not give any numbers at all, we can put it in the end because it doesn't matter. And it also won't prevent us from gaining some impression. So we assume that all albums that we are interested in, they give at least one unit. So in this case, they have to be sorted in order of increasing their maximum. Yes, so we just sort them in the increasing order of their maximums. And that's it. I think that's it. No, we need to take some subset and sort it with increasing maxima. We need to take some subset. Okay, so in the beginning it is 0. So the maximum coolness is 0 because we didn't listen to any tracks. After that, we took some array. So it's like dynamics. It's like dynamic programming. So kinda so at some moment, for example, we have some album and it has several maxima. This one, this one, this one, this one, and this one, for example. So in this case, we need, if we want to get this number to be the maximum, we need that previously the maximum was less than this number. Okay? So actually it's like dynamics where for each number we know the maximum number of impression that we can gain if the maximum was less than this number. Yes. So to approach this, we read n singular number. Why singular? Why just not single? Great. So we take number k, we read k, we say that vi dot y dot resize k, and we read vi. Then we say that not vi but vi dot y. Then we say that vi dot x is maximum max element, I guess, of the whole vi. Dot y. Then we sort them. What do we do next? And we need to get the maximum impression that we can. Yes, so, okay, let's go through all vectors. So, first of all, we need to find all prefix maxima. Let's go from j equals 0 to j less than vi dot y dot size. So if vi dot yj is greater than mx, we say that mx is equal vi dot yj, and maxima indices dot pushback j. Excellent. So then we go through. Also, I need to find all maxima. And here we say that cout ant.back. Yes, so here we say that I even think that we need to make n+1 here. So what do we do? We say that let's go again through j equals 0, j less than maxima indices dot size plus j. So assume that we take this index j, and each should be the first maximum. In this case, we add to answer this number. It's maxima indices dot size minus j. This is the number that we add to the answer. And also we need to find the answer that was previously before this index. And I think it is just so we take lower bound of v with element like vi dot y maxima indices j and empty array. I think empty array. I cannot make it like this. Like this? Okay. No? What's wrong? What's wrong? Ah. No. I thought the sentence error. It's nonsense. Ah, I get it. I need to subtract v dot begin. And I can even make it here like this, I think. No? Are you crazy? Okay. So this is lower bound index. And I just say that ans I plus first equals maximum of ans I plus first and ans of lower bound index and new ans here. Yes, it should be okay. It should be fine. Yes, it should be really fine. It is not. Just a moment. Where is stack? Ah, it's here. Why is it here? Okay, so we have a problem right here. Four. It's kinda correct. It is kinda correct. Let's make some tests because I'm not sure. So we need, for example, 3 arrays. 1, 2, 3, 4, 5. No, 1, 3, 5. And also 1, 2, 3. And also 4, I think. For example, like this. 5. And what about 2, 3, 4? Again 5. Ah, because I still can do it. And what about this? Again 5. See? We cannot. Okay, I think I believe it. Though, I guess it can be wrong answer again, and I will tilt. No, it's not wrong answer. So we are happy. But still, our place is disaster. Problem D. So we have an oriented graph. And we can spend, in each vertex we can spend one performance or more performances and gain WI coins. And we need these coins to travel through the edges. And we need to get to the final city, from the city 1 to the city N. So I think it looks like this. It looks like this. We have our first city, our last city. We make some performances in the first city. Then we go to some city in which we have the greater cost of the performance. So Vi is greater than V first. Then we make some performances here, and then again we travel somewhere with the greater cost of the performance. So Vj is greater than Vi. Then we make some performances here, and again and again and again, and finally we come here. So first of all, let's sort the cities by the increasing cost of the performance. N is at most 800. So let's sort the cities in increasing order of performance cost. So I think maybe with just Floyd algorithm we find the cost of getting from each city to it's not Floyd, it's Ford-Bellman algorithm. From each city to then all cities to the right. Yes. It's like MN. We spent MN on this. Okay, and then we support some dynamics. So we try to get to the city with ith performance, with as little performances as possible. Yes. Okay, let's try and do it. Element B. Then W. Okay. So first of all, what is the possible answer? Possible maximum answer is m times, no, I think n minus 1 times 10 to the 9th. So the maximum possible answer is 10 to the 12th. Yes. So what do we do here? First of all, we find the cost to get from each city to the other ones. And here we say that so we have read all edges, and now we need to no, we need to store all edges. Okay, now it's float algorithm. So here we use lambda to sort the indices. And we return that VA is less than VB. So, and here we say that ans back, if it is equal to inf, we say -1, and else we say ans back. Ah, no. So if J index is greater than 0, is at least 0, then perf W is maximum of perf W and W of J index. And also so if J index is at least 0, So I have found a bug. It is here. It should be just j. So if j index is at least 0, and then we go from Cj to I, and otherwise we go from 0 to I. Okay. So parallel left part is if j index is at least 0, we take ans j, else we take ans 0. Okay, let's just make it with an if. So assume that j index is at least 0, then we need to get from j index to I index. How do we do that? We say that we need money, which is equal to cost from j to I minus the money that we currently have. So if needed money is less than 0, is at most 0, then current ans equals left part dot x and minus needed money. Otherwise, it is equal to what? Then we need to divide needed money by the cost of the performance. So if needed money is greater than 0, then needed performances equals needed money plus perf minus 1 divided by perf. And then current ans equals PLL of left part dot x plus needed performances and the money that we have. This is minus needed money plus needed performances times perf w. Yes, and this is also correct if j index is less than 0, but in this case we need to replace this number with something else. So j index is at least 0, then this, else this is from 0 to I. Okay, so here we say that if current ans is less than ans, and ans I. I spent a lot of time. The answer is not correct. First of all, why did this happen? I think I need to say that on the diagonal I have zeros. Maybe this will help. No, this did not help. Okay, let's have a look at this test. What do we have here? For some reason, the answer is less than we needed. Hmm. Okay, I think it is like this. So 4, 40, 12, minus 1. And this is not correct also. So let's consider this test case. So what happens here? We have 4 cities, and initially we have 10 coins. What is it? Ah, profit from representations. Why representations? Ah, представление in English is both performance and representation, but representation is not like magical performance. So we have 4 cities, 1 with cost 1, 2 with cost 2, 3 with cost 10, and 4 with cost 1. So we have several edges. First of all, from 1 to 2 costing 20, from 2 to 4 costing 30, from 1 to 3 costing 25, and from 3 to 4 costing 89. And the answer is, it should be 24. So I said, and initially I have 10 coins. So I can make 10 performances here and get here. And also make 15 here and end up with 25. But also I can make 15 here, get here, and then make 9 not presentations, but performances. But why 40? 40 is way too much. Ah, maybe I get it. In the end, I need to calculate the answer. So, if C I back is infinite, then continue. If ans I dot x is at least inf perf, then continue. Otherwise, I again calculate needed performances and needed money. So needed money is ci dot back minus ans I dot y. So if needed money is at least final ans, no, if needed money is greater than 0, then needed performances equals this. And when we calculated it, we print, we don't print, say that final ans is minimum of final ans and ans I dot x plus needed performances. So it's now 24. 4, 24, 10 minus 1. Now the answer is correct. Wrong answer, test 3. The contest is going very wrong very quickly. So the answer is maximum 10 to the 12. It is the most possible distance actually. How did I fail it? It's not a hard problem. So answer is no more than this. Okay, let's try. This is not a good practice, but nevertheless. Okay. Okay. This is fine. Incredibly bad translation is hung for the city 1. Подвешен за. There is one gas station in each city of Berlin. Gas stations have special pricing, and for each gas station there is a fixed range of prices for fixed range of prices for which they are ready to sell gasoline. I don't know. Gas station in the city with the number I is ready to sell gasoline. Gasoline. I think it's gasoline. At any price from Li to Ri inclusive. I think we do not need to solve problem E because problem F is way more popular. Ah, mathematics. What is this word? Junctions of the lobules. Incision. Where did they get these words from? Incision. So we need to get at least k pieces. So first of all, we cannot vary we cannot vary AI, we only can vary BI. So these two numbers don't matter. So we need to maximize this number. We need to maximize this number, knowing that this is true. So maximize product of AI. Let me write it like this. If prod of BI is at least k. So we need to maximize minus this. So first of all, if we were able to make exactly k, and we were able to make all these numbers integers, then everything is fine. So actually we can rewrite it like this. So it is like AI minus AI mod BI divided by BI. So let's take B equals prod of BI, A equals prod of AI. So we need to maximize product of A over B times product of 1 minus AI mod BI divided by AI, also known as 1 minus AI BI what is it? No, it's not correct. Where B is at least K. So if we could make B equals K, then this is a constant. And if we also made everything divisible, all AI are divisible by BI, then this is also 1 and we won. The problem is, it seems not very easy. We need K parts. Also, it is rewritable in the way AI over BI minus AI divided by BI fractional part. Maybe we can try something random, but I don't think so. I don't think we can try something random. So if the product of these numbers is divisible by k, then we win. But what if not? Actually, if not, I think we need to increment this number until it is finally divisible by it finally divides the product of these numbers. So assume that. So what do I mean? No, I think I am false. So first of all, the answer is at least 1/2. Why is it at least 1/2? Because if there is why is it? Yeah, because if it is less than 1/2, then I think we can remove one division operation. And the number of pieces is still will still be at least no? No, it's not true. Not 1/2, but maybe something like this. Maybe 1/3 and 1/4 or 1/4. They are genius mathematicians. Genius mathematicians. Okay, let's return this back. So we just need to maximize product of what? One over bi minus ai over bi fractional part. And this all is multiplied by k. And this all is multiplied by k. So if we know the exact number of pieces, this still doesn't help us a lot. Okay, the number of pieces cannot be more than 2k, because if it is more than 2k, we can just remove one slice, and this is not one slice, but one, I don't know, operation. And this is divided by 2. So the number of pieces is at least 2, is at most 2k. It is from k to 2k. Also, the error is very little. Okay, so actually I think we can say the following thing. So there is some dimension. Let's draw like this. So this is dimensions from 1 to I minus first. This is the ith dimension, and this is from I plus first to nth dimension. In this case, we can say that the number of pieces of division into these dimensions is at most, I think, like square root of 2k. And here is also at most square root of 2k. And here it might be more than square root of 2k. Okay. So we find the maximum piece in case of such division and in case of such division. And in the end, we iterate over these dimensions. And we ask, so if here and here there were this many divisions, then how many divisions are here? But this is too much. I think this is too much. Ah, then we can combine them somehow. We can combine them somehow. But how? So it's like AI, like CI is maximum possible BJ AJCK where JK equals I. Like what? Okay, first of all, I think we can agree that it is like K here. And even more, I think we can agree that it is K half here. Yeah, so let's take the optimal answer. Let's take the greatest prefix, in which it is at most square root of some constant, in which there is at most some constant, and some suffix in which there is at most some constant. So since we cannot add this, here is at least 2. I think it is something like this. Just a moment. Yes, we can actually take floor of the root. So what? So yes, we have square root of k here and square root of k here, but that's not good enough. now we need to combine them. We really need to combine them. And how can we do it? And what after we combined it? We just take something like maximum of AI over BI lower bounded. No. I think we can just try to write it and see what happens. Maybe we need some pragma. Okay, let's try. Let's try. So first of all, we need square root of k. Okay, now we need some prefixes and suffixes. So here we try to find I plus first, knowing that we have first I element and we are trying to add AI. Yes. Okay, so we are going through we do like this and like this. Then we make it at most k. Here we make it at most k. We need to be at most k. So this is at most k over j, I think. And here we say that left I plus first j times k is minimum of left j k and what? And k. No, and we need to find the volume. Ah, there are also some double operations. I don't like it. There are some double operations, which I don't like. No, it's not good to use k here. Let's make it L, because at least this number of pieces. So we take left I, not left I, but left I j. After that, we divide in this number of pieces. And divide it by AI. Okay, the same goes for the right one. Right is like, again, how many pieces do we use? Here we replace AI with a n minus 1 minus I. So, in the end, we need to iterate over all pieces and say that we say that current ans equals something, No. Here we iterate over j and k. What do we do here? So we say that, first of all, we divide the left part, left I pieces into left I dimensions is into j pieces. So it's left I j. Then we also take right n minus I minus 1 pieces and divide them into k parts. And finally we need to divide into L plus so we also need to divide our current dimension into this number of pieces. So if current dim is greater than a I, then continue. And actually we multiply it by these strange numbers. So we take okay. Not really great, because it should be minimum. And also this should be minimum. I mean, this should be minimum. No! This is not nice. What happened? So we need 2 and 3. We need 2 and 3, so here I should be equal to 1. Yes. And we take j equals 2 and k equals 1. Why is it 0? Because left ij is 0. Why is it 0? Left 1, 1 is 0. Why did it happen? Because it should be maximum. .9 and why? Current tons times k. Times L. So for some reason it was .3/20. And why? How is it possible to make 3/20? It is not even divisible by 4. Okay, let's see. I chose I1 and J2. So I1 and J2. But it is not possible because in this case I1, J2 and K1. I get it. So it's exactly like this. But then left ij cannot be 1/2 because it shouldn't be. It should be with denominator 5, not 2. Why? Let's see. So now AI equals 5. Yes. Left 1 is 1 and left 2 is 0.4. Ah! Oh no. 0.8. Yes. Nine 8507. 0. Okay. It is now already slow. It is very slow. It's almost 2 seconds. It's 1 second, I mean. And now it's already 2 seconds. It's not good. Okay, let's try it here. No, we cannot send this. We cannot send this. Guys, it's really sad. It's just sad. It is really sad. We need to somehow make it faster. We need to make it faster. What about the final stage? We need to make it faster. The final stage should be faster. So here we have what do we need? We need j times k times m is at least l. So k times m is at least CL of L over J. So actually so either K is it no, I mean some of them should be at most square 10. Is it true? Yes, it is true. So K is at most this or M is at most this. Okay. There are two options. First of all, we iterate K. So it is at most K or ceiling of SQRT of L minus 1 plus J over J. And here we iterate till upper bound. And after that, and here we say M. It is easier. And now we say M from 1 it is at most AI or this, yes. So M from 1 to this, and here we say something like this, and if K is greater than K, then we continue. Yes. Maybe it will be better. Yes, we sped up. We sped up. I think we can really submit this right now. Wrong answer on pretest 21. Okay. Actually, I will just do like this. Still wrong answer. Ah, I get it. We need to fix these arrays. So okay, how do we do it? We say that left I plus 1 j is maximum of left I j and left I plus 1 j. And the same goes here. And also plus 1. Yes. This is failure. Okay, and we will try again. Excellent. What can we do now? We kinda can try and solve E. Okay, we can lock problem C and hack someone. This is what we'll do. What's... Ah, here's tourist. Why am I... Why am I with tourist? He will... He will hack everything that I didn't hack. What is it? Bit set? What is it? Why did he needs a bit set? Segment 3? Oh boy. Oh man. So this is very similar to what I have. So store is the set of all numbers, and for some reason without repetitions. Ah, this is for compression. I understand. So what is compress? Compress is like map? Ah, it's like a giant array. Okay. For some reason we compressed everything. But numbers are no more than 200,000, so I don't understand why a compression is needed. But okay. Okay, maybe it's not that bad. Ost is like set in which you can get indexed by the element. Okay. Honestly, I'm too lazy to look into these solutions. So I will start the editorial for you. Oh, somebody solved G. And maybe he's top 1. Filterator was hacked. It is funny. Maybe I will also be hacked. But if somebody hacks me, I cannot do anything about it. I spent so much time on it. See, more than an hour. Incredibly much time. Fine. Problem A. This is a constructive problem. And in this problem, somewhat strange condition is given. So for every 4x4 submatrix, you need the following. So the XOR in this square should be equal to the XOR of this square, and the XOR of this square should be equal to the XOR of this square. And this is true for every 4x4 submatrix. 4 times 4. How do we approach it? Actually, I think there are billions of ways to approach this problem, but the simplest for me was the following observation, that we just can make each 2x2 square XOR 0. If we do it, then everything is 0, so both red squares have 0 XORs, both green squares have 0 XORs, and we are happy. How to make all XORs zeros? Actually, the easiest way is make it something like this. We can choose a number for each column, AI, and a number for each row, bj. And in this case, the number in their intersection is AI XOR bj. Why is it useful? Because in this case, if we choose any 2x2 square, what are the parts of the compound? So assume that this column has number A attached to it, this column has number B, this row has number C, and this row has number D. Then this is, let me introduce some Roman numbers. This is A XOR C. This is B XOR C. This is A XOR D. And finally, this is B XOR D. And see how all bad numbers cancel out. This A is cancelled by this A, this B is cancelled by this D, B, this C is by this C, and this D and by this D. It is caused by the fact that in the field modulo 2, it has the characteristic 2, so if you sum any two numbers, you get 0. And because of commutativity and associativity, all these numbers cancel out, and you get 0. So you just need to choose a number for each column and a number for each row, and the only thing that you need is that all these numbers are different. And this is also kind of easy. You just make them independent. So all zeros and ones here should be from bits from 0 to 7th. So this is numbers from 0 to 255. You only use 8 the 8 least bits. And here you use 8 greater bits. So from 8 to 15. These numbers of bits. So since 256 is at least this number, it is possible that you just do it. So formula is kinda easy. You can see it here. So just the number of row times 256 and plus number of column. And all these numbers are always different. So you just get what you need. Actually, here I could use XOR instead of plus, but since these bit sets are just, they're non-intersecting, because j is less than 256, we are okay. Problem B. So we have two columns of numbers. And from each of the columns, we take the first number or the second number. And we need the maxima of this and this column be as near as possible. For example, if we took, let's consider some example. 5, 1, 5, 2, 7, 3, 3, 4, 10, and 2, 5. For example, if we chose this, 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 and this, then the maximum is this number, and the maximum is this number. So the answer is 7, the difference between these two numbers. But actually, you can do better. Instead of choosing these random numbers that I chose, you can choose here 4, here 5, here 2, here 3, and here doesn't matter, for example 5 again. So in this case, here maximum is 5, here maximum is 4, and in the difference is 1. And as you see here, the difference is 1. Filterator didn't solve C. This is sad. This is sad. Okay. How do we solve it? First of all, you can just sort pairs because the order of pairs doesn't affect the answer. So you can assume that the numbers here are sorted. For example, 1, 2, 2, 2, 3, 6, 10, 10, 11. Something like this. And here they are not necessarily sorted, because you cannot do anything about the order of B's. You can only change the order of A, and if you fix it, you cannot do much about the order of B's. Okay, after that, let's choose. So we know that there is some answer in this problem. So let's find the lowest number in the answer. For example, this one. The lowest A in the answer. In this case, you already know the maximum in the left column. It is this number. For example, if it is I, then you know that the answer is AI. So what do you know about B? First of all, you have to take all these numbers. I will draw with another color. You have to take all these numbers because you didn't take A in these rows. Also, you cannot take this number. And you can take any subset of these numbers. Any subset, but if I equals n, then so let's call this subset B. Then B should not be empty, because otherwise you are left with an empty set, and this is sad. Actually, this is not necessarily, it's not necessary to do. You can just say that the maximum of an empty set is minus 1, minus 10 to the power of 9 minus 5. And in the case you chose this number, it means that it is way worse than you could do. So if you make any choice, then the answer is no. Yes, if you make any choice, then the answer is 10 to the 9th minus 1. But if one of the numbers is this, then the answer is worse than that. So you can just say that the maximum of empty set is this number, and in this case you don't need to consider this extra case. So what do? We maintain these two sets, the set of B and the set, let's call it C. First of all, you always take maximum of C, and you can try this number, AI minus this maximum. So this should be tried as an answer. What else can we do? We can also take some of these numbers of the set B and try it. So using set int lower bound, you can take two nearest numbers to 10. For example, you can find here, I don't know, 8 and 11. And you can try both these numbers. The problem is, it is not always possible. What I mean here is that if these numbers are less than maximum C, then you cannot use them, because maximum C will be the maximum instead of 8 and 11. So you can try both these numbers, check if they are greater than maximum C, and if they are greater, then you can try them. And you should never try this number, because it is impossible to try. So I explained the solution in case when I is fixed. But what if I is not fixed? Well, because you should iterate through all i's in this array. So when you go from this one to the next one, you need to change these two sets. First of all, you need to remove this element from the set C, and secondly, you need to put this element to the set B. And actually, since there can be any repeats, you should use multiset here, multiset int. Okay, that's it, I think. Problem C. Problem C goes as follows. You have several arrays, and you need to concatenate them in such a manner that you maximize the number of prefix maxima. First of all, as I said during solving this problem, assume that you have an array that didn't give you any units of impression. 0 point. So at any moment, your current state is just your prefix maximum. So when you're asking whether this piece of music will impress you, the only thing that you need to remember about the past is what is the prefix maximum. Anything else doesn't matter. Only prefix maxima are included in the current state. So So assume that you know this number. Yes. And moreover, the less this prefix maximum is, the better it is for you. So if you could magically decrease the prefix maximum, then you could only increase the answer, because you will get more units of impression. So assume that you have a segment which didn't give you any units of impression. Then actually you can put it in the trash, because if you remove it, you only decrease the prefix maximum for future tracks, and this is better for us. But we cannot move it to trash, because all pieces of music should be listened at least once. So the solution is put it in the end. If you put it in the end, it doesn't bother us. So we can assume that, first of all, we have several segments in which each segment gave us some units of impression, and in the end there is trash can, where we have all tracks which didn't impress us. The second thought is that here all maxima should increase. So assume that here we have some maximum m, and here we have maximum m which is less than m. In this case, when we approach this playlist, approach this album, we already have all these now. We already have prefix maximum greater than all tracks in the current album. So none of these tracks will impress us if m capital is greater than m lowercase. Hence, you didn't need to do that. Even if you have something like this, this is not optimal. You can actually swap these to I mean, if you have m capital is at least m small, then this can as well be put into trash can, because it won't impress us. So in this part of the array, maxima are strictly increasing. This is what I want to see. So let's take all albums in the increasing order of their maxima and consider two cases. We can either put it here, or we can put it here. If we put it here, it doesn't change any answers. If we put it here, we need the following thing. What I also needed to say is what are the elements which have any chance to be giving us the impression. It's actually the sequence of prefix maxima of this array. Or else, it is what tracks will impress us if we put it in the beginning of the playlist. This is the sequence of prefix maxima. So this element is greater than all these elements, this element is greater than all these elements, etc. And somewhere here, I mean even here, is the maximum of the whole sequence. And here is the first element. First element is always the prefix maximum, one of the prefix maxima. So let's find this maxima, and what I want to say is let's choose the first of these songs which will impress us actually. Let's assume that this is this one. First of all, it means that all these songs will also impress us. Secondly, it means that the previous maxima should be strictly less than this number. So the solution is as follows. you go through all the tracks and you maintain DP. DPI means maximum number of impressions by albums in which maximum is at most maximum in ith album. Ith in the order of increasing maximum. So first of all, let's remember till the end of this problem that these albums are sorted in the increasing order of the maximum coolness, level of coolness. And DPI is the maximum number of units of impression generated by this subset of albums. Then what do you do when you consider each next album? You iterate over all prefix maxima. You consider the case when this is the first track that impresses us in this album. And this means, for example, this is I. This coolness is C. Let's find the place in this array such that here all coolnesses are less than C and here all coolnesses, maximum coolnesses, are at least C. In this case, we can only use these tracks to impress us. So the answer will be dp I, where I is this place, and this place can be found via binary search. This is a reference to Umnik's famous phrase that you should learn how to use binary search. This is kinda it. And you add the number of these tracks, which all will impress us. And you iterate over these all numbers, and the maximum of these sums will be dpj, where j is the number of this album. And in the end, the answer is dp last dp. Okay, problem C is finished. Problem D. So in problem D, you have several cities. In each city you have some cost of performance. So if you make a performance, you gain WI money. And also there is city 1 and city n. And you want to get from 1 to n via some flights. But flights cost some money. Initially you have P money, and for each flight there is some known cost. So if you do not have enough money, you can make some performances until you can fly the next edge. And the question is, what is the minimum number of performances you need to organize to move from 1 to n? Okay, to solve this problem, you actually need to understand that sometimes you do not need to make a performance. So, for example, let's assume that you have been to a city where the cost of performance is 1000, and after some time you have moved to a city where the cost is 50. And you run out of money. Then of course you will make some performances here, but this means that you have been unoptimal. because each time you make a performance here, it is a lost opportunity to actually make a performance here and make 950 more money. So what I want to say is you only make performances in prefix maxima of your path. If you have been to a city with 1000, you do not anymore make any performances in the cities with less performance cost. But we can exploit it, and actually when we are in some city, we can still make performances of cost 1000. What it means in reality is that we move to the past, to the moment when we are in this city, make a performance here, and now when we are in the city X, we have 1000 more money. So it looks like we actually made a performance not for 50 but for 1000 coins. In reality, we just made it in the past. So the problem is like this. You can move from city to city, and if you want, you can make a performance of the cost maximum of the visited cities, and you need to move to N. So the solution consists of 2 or 3 steps. The first step is just Floyd algorithm. It's just you, for each pair of cities, you find the minimum cost of getting from the first city to the other city. And this can be done in n cube time. So for each pair of cities, you can find the time you need. You can find the amount of money you need to spend to get there. So after that, we start. We consider our path like this. So first of all, we are in city 1, and we can make 0 or more performances in the city 1. After that, let's consider the next city where we made a performance. Let it be city B. Actually, we need to find the most cheap way from 1 to B. Because since we do not do any performances here, we do not need any more expensive trips to some other cities, because we can. So the only reason why we need to go somewhere using more expensive flights is because we want to make a performance on our road. For example, let's see that this is city 1, and you can get here for 100, or you can go here for 1 and then go here for 1000. So obviously at first you would think that you only need to go like this by the lower route, but assume that the cost of performance here is 1, the cost of performance here is 1 million, and the cost of performance here doesn't matter. Then, and you do not have any money initially. Then to get here you need 100 performances. But if you use the upper route, you need 1 performance to get here, and then 1 performance to get here, and also you have 999,000 money left. So you used the upper root, although it is longer. And the reason is because you make a performance in an intermediate city. What I want to say is that if you do not do any performances in the intermediate cities, then you only need the shortest path, which is found via Floyd's algorithm. And then, for example, you have visited B, made some performances there, and then you go to some city Q, also via several edges which form a shortest path between P and Q. Note that this might not be the shortest path between 1 and Q, because we didn't need to visit P, and we only visited it because we needed to make some performances there, and this could make our route longer, and etc. You make performances, and each performance cost is greater than the previous one until you get to the city N, where you do not make any performances, you just relax there and you win. So now, after this Floyd's algorithm, we consider this sequence of cities, and you notice that the cost of performance is increased there. So let's find these dynamics. For each city, we want to find the minimum possible pair. What I mean by the minimum, the first element is the number of performances you needed to make to get there. And the second number is the amount of money that you are left with after doing it. And this should be minimized, but the amount of money left with you should be maximized. And for each city, you just find these two numbers. So if you have several pairs, firstly you choose the pair with the minimum first number, and if there are still several pairs with equal first number, you choose the one which has the maximum second number. And how can you find these pairs? You just iterate from the first city to the last city, and cities are in the order of increasing performance cost, because these blue circles are also in the order of increasing costs, and you only need to get to some city from some city with less performance cost. So how do you actually do it? You choose a city, not choose, but when you iterate, consider some city I. You iterate over all cities J with less performance cost. And via Floyd's algorithm, you find the minimum possible cost to get from here to here. Then you calculate this pair. What is this pair? First of all, you find the best pair here, and you have already found it because of our order of considering these cities. Then, if this maximum number is enough to make all these flights, then you just do them. And if you cannot fly because you will run out of money, then you make as many performances as you need to make this number at least what you need, and then you make these flights. The actual formula can be seen here. I also considered the case if this city doesn't exist. So this is city 1, I think. But actually it was not correct. but I will not explain how I should have done it. So you can assume that j index is at least 0 always. So where is this formula? So needed money is CJI. How much money you need from CTJ to CTI. Then you subtract the money that you have. This is this element. And this is now this is how much money you need. And if this number is less or equal than 0, then you do not need to make any performances. And if this is greater than 0, then you just divide with rounding up this number. And in the end, you say that you made this many performances plus the number of needed performances. And the money that you now have is just this difference. That's it. Okay. And finally, you iterate over these possible cities, and again with the Floyd, with the result of the Floyd algorithm, you find the minimum number of performances to get from here to the nth city. This is again made here, and this is very similar to this part. Okay. I think I finished with problem D. Problem... I didn't solve problem C? Oh no. My solution of problem C maybe it has failed. Why? I cannot see it. What's wrong with my solution? Oh no. So I believe I said correct solution to you, but maybe the implementation was wrong. Okay, so problem E wasn't solved by me, unfortunately, so we end with problem F. Problem F is somewhat messy mathematics, but what we end with is the following. You have several numbers, A1, etc., AN. You need to find some numbers B1, etc., Bn, so such that the product of these numbers is at least k, and these numbers should be maximized. So first of all, product of AI over BI divided by AI, and all this product is multiplied by K. So this number should be maximized. So this intuitively, this property says that the numbers BI should be big, and this property says that the number BI should be little. Oh, I'm sad because of problem C. What happened with it? Okay. And K is at most 10 to the 7th power, and AI is also at most 10 to the 7th power. We will call this number and this number. So we have N and we have K capital, which is at least K and all AIs. And we will explain our asymptotics depending on these two numbers. So, first of all, it's kind of ideas of square root decomposition. If you have several numbers, first of all, if you can decrease some number BI such that their product is still at least K, then you want to do it because you will increase this number. So all BIs should be as little as possible depending on this condition. So, for example, this means that this product is at most 2K. Because if it is greater than 2K, then you can decrease any B which is greater than 1 by 1. And you will so you can decrease any BI by 1, for example, BI to BI minus 1. And you have multiplied your number by BI minus 1 over BI, which is at least 1/2. This means that if you decrease this BI, you still will get at least K. So you can, for example, assume that the product of all numbers is at most 2K. The fact that I used is actually that you can find an element such that this product is at most square root of K, and this product is also square root of K. I will prove it to you. So assume that there is no such element. Let's just take prefixes one by one. So B1, B1 and B2, B1 and B2, B2 and B3, etc. and we stop. We continue while this product is at most square root of k. So let's assume that this is the biggest such prefix, and if you increase it by 1, then it will be greater than square root of k. Assume that this is not this good element, then if you make the same process from right part, this will mean that you have at least 2 such elements. So this is the biggest prefix, which is at most square root of k. This is also the biggest prefix, such that this is at most square root of k. And there are also 2 sum elements. And this means that if you increase them both, then they both are greater than square root of k. I think this might... I think actually I needed to put 2k here, but let's hope that nothing bad happens. So if we have this, then actually the product is greater than 2k. But if it is greater than 2k, you can decrease any of these 2 numbers and it is still at least k. So actually there is at most 1 such element. And since this is at most square root of k, there is exactly 1 such element, except the case k equals 1, in which everything is fine. Okay, so we have such picture. Actually, I think my solution can fail because I used square root of k here, and there should be square root of 2k. I think I will be able to hack my own solution if I want. But let's see if it's possible. Okay. Okay. So as I proved, we have the following structure. We have some element, and here we have product, which is at most square root of k, and here we also have a product which is at most square root of k. Okay. Actually 2k, but this doesn't matter. Okay, k times some constant. What do we do next? We will find for each number n, okay, for each number m, what is the least possible, what is the maximum possible product, like I said. So product of bi over ai divided by ai. Yes, what is the maximum possible? No, sorry. ai over bi divided by ai product. So for each and such that sum of bi maximum possible product where sum of bi is at most k, and product over until j. So this is dpjk. So for each prefix and for each number of pieces, you find the maximum possible pieces in case that so many pieces were made. The same goes for the right part. And the time that you make it into is not very big. Like n times k. K is a square root of the k in the statement. And here something like k over j. I think it's k log k. Okay, so in this time, you can find all these dp's. This is dp left, and also you can make dp right. Okay, so now we have this element, we have this prefix, and we have this suffix. And the answer is combined of these three parts. So you choose the number of pieces here. Let's make some indices. For example, let's assume that this is index I. So the length of this segment is I, and the length of this segment is n minus I minus 1. Then and we think that we choose j elements here. K elements here and m elements here. Then the answer will be dp dpl ij times dpr n minus 1 minus I k times something here. What do we do here? I guess just AI over M divided by AI. So the product of these three parts. And the only thing that you need is to maximize it in case that j times k times m is at least k in the statement. Sorry that I have coinciding variables. Let's call this k prime, if it helps. So k prime here. Okay, naive method works in O of k time, because you iterate over all these numbers. Accepted. So you iterate over j, which is from 1 to square root of k c. You iterate over k prime, which is also from this to this. And you do not iterate over all m, because if you know j and k prime, you do not need to iterate over all m. You can just make the minimum possible, which is this. But still, this is O of k, which is too slow because you are also multiplied by n. So because of that, you actually need to again apply square root decomposition. Namely, you do not need to iterate. So if both j and k prime are very big, then actually k is there will be same numbers m for several values of j and k prime, and you do not need to iterate over all of them. So actually you go here not till this number, but till square root of k over j. What do I mean? I mean that all you need from numbers k prime and n is that k prime times m is at least k over j. And this means that one of them is at most square root of this number, because if both of them are greater, then you can decrease one of them. So you just iterate k prime over it and m over it, or over the square root. And this ends up into something like integral of square root of k over x from 1 to square root of k, which is square root of kx in point square root of k, which is k to the power of 3/4. Okay, so I think asymptotics is like k to the power of 3/4 times n. I think it can be even be better. I think one can make k to the power 2/3 times n, but I did not do it. But it is possible, I think, if you make cubic root decomposition on these three numbers. So finally, we just calculate the answer. What I also wanted to do is to uphack myself. But I still cannot. I still cannot uphack myself, because is it still possible to uphack somebody? Yes. So I need to wait till the end of the contest. So I have some time to find a hack. Still +4, it's funny. I still don't know why my C has failed the sys tests. Okay, I will think a while about my uphack, 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 uphack. There are some problems with Codeforces. Yes, there are some problems with Codeforces. Okay, while I have time, I will make some stressing. And correct answer is something like it, but here we need to, let me think. K should be doubled. So we need to generate test. And say that if A So Codeforces failed. Codeforces crashed. Okay, this is something like stress, and all we need is make a test here. Okay, so what I need here is make a test such that we actually need here 2k. Or else it doesn't work. Ah, maybe it's not possible. Even if it's possible, it's not likely to be an easy test. Maybe something like this. One. Like 5, 5, 24. Or even 2, 2, 3. Okay, I found a test. It's as easy as this. But I cannot uphack myself because Codeforces is down. Guys, it's frustrating. I want to uphack myself. At least we get something. It's 502 bad gateway, but it's still something. Ah, I can uphack myself finally. Or can I? What? Unexpected verdict? What the hell is this? Okay, let me try to hack some Codeforces. What's happening? Okay, I guess it's not possible to wait till the Codeforce still works. Maybe I will try one more time, but I guess we will just have to wait. But as you see, this uphack worked. Okay, I will try first of all uphack with something else. Okay, no, I will not try anything. Or will. Maybe something else? Maybe they also have incorrect solution themselves. And that's why they get it. I don't know. Okay, I may try something else. For example, I don't know. Okay, let me try something else. For example, Okay, as you see, we are unable to make this expected verdict, so actually my solution of F is really wrong. Because of this constant. So this should be like 2 or 3 or something. Let me resend with correct number. Wrong answer, test 1. Why? Okay. I have done everything I could. So thank you for watching.